Chapter 6, Lesson 1 and Lesson 2 focus on equivalent fractions. Let's go ahead and take a look at what a fraction is. This is the first lesson that we're talking about related to fractions. So a fraction is a part of a whole. The numerator, or the number on top, is the part of our fraction that indicates how many parts we have. The denominator, or the number on the bottom of the fraction, indicates the total number of parts that make up the whole. So if we look at this rectangle over here to the left, it's split into 3 pieces. The 3 indicates our denominator. That's the total number of pieces our rectangle is split into. And then the 2, our numerator, indicates the number that are filled in, or the parts that we have. So fractions are less than a whole. We don't have this entire rectangle filled in. We only have part of our whole, which is what a fraction is. Okay, so let's talk about equivalent fractions. Equivalent fractions are fractions that name the same amount. If 2 numbers are equivalent, or 2 statements are equivalent, then they're equal to each other. They represent the same amount. So in this case, we're talking about fractions, and we want our fractions to represent the same amount. Here I have a circle, and I'm going to split this circle in half. And now I'm going to fill in half of my circle. So what I have right here represents 1/2. I have 2 total pieces in my circle because I split it in half, and one side of that is shaded. Now what would happen if I split this in half again? Notice that the purple side doesn't change, but the number of parts that I have in my circle now do change. So instead of having 2 parts in my circle, I now have 4 parts in my circle. I have 1, 2, 3, 4 parts of my circle. So that's going to be my new denominator, or the parts in my whole circle. Now I'm still looking at the parts that are shaded in purple. Now instead of having just 1 part that's shaded in, I have 2 parts shaded in. So my new fraction is 2/4. These fractions are equivalent. They're equal to each other. All I did was draw another line across my circle. I didn't change that amount and what that amount was worth. So 1/2 is equal to 2/4. Now let's take a look at a rectangle, and we're going to split this rectangle a few ways, and we're going to see how the different pieces that we can make that are equivalent to this rectangle, and we're going to see, well, what can we think about in terms of equivalency? How can we create equivalent fractions? All right, so here I've split my rectangle into 3 equal parts. The equal parts is important. Now, with my drawing, they're not exactly equal, but use your imagination. So I have 3 equal parts here, and I'm going to shade one of these parts in with my red. So I have 1 out of my 3 pieces shaded in of my entire square. So this is going to equal or represent 1/3. I have 1/3 of my square shaded in. Pretty simple. We know this when we just look at it. How can I change my actual picture, though, to change the number of pieces that I have, but find another fraction that's also equivalent to 1/3? Well, I did something similar with the last circle. All I did was cut it in half. So why don't I do that with this circle? I'm going to just cut my circle in half, or cut my square in half for this one. All right, so I took my pen and I cut my square in half. How many pieces do I have now? If you count them all, we would have 6 total pieces. And how many are shaded in red? 2 of those pieces are shaded in red. So here I have 1/3 is equivalent to, or equal to, and I can put my equal to sign here, 2/6. All I did was split it again. How else could I split this so that I have more pieces, but also find a rectangle that's equivalent? Let's start off with 1/3 again, and I'm going to find something that's equivalent. This time, instead of just drawing one line down the middle, how about I draw and split each of these rectangles in half again? How many pieces do I have now? Well, if I count them, each column has 4, and I have 3 columns of 4, so I have 12 total columns. So I have 12 total pieces. And how many pieces are shaded in? 4 of them. All right, now what's the connection that I can make between my 1/3 and my 2/6, or my 1/3 and my 3/4? What do you see that's happening to my top number and my bottom number? I split it in half, and my numerator and denominator increased. I split it in 4ths, and they increased even more. What relationship can we create? Well, when I'm going from 1 to 2, what's happening? Am I doing the same thing with my denominator? I am. So 1 times 2 equals 2, and 1 times 2 3 times 2 equals 6. So I went from 1/3 to 2/6 by multiplying times 2. If I look at my next fraction, do I see a similar pattern? How did I go from 1 to 4? I multiply times 4. How do I go from 3 to 12? I multiply times 4. So whatever I did to my numerator, I also did to my denominator. Let's see if this holds true for a different shape that we're going to cut a little bit differently. So here I have a square again, but instead of just cutting it into 2 pieces, I'm actually going to split this square into 4 equal pieces. So I've split my square into 4 pieces, and I've shaded one side. So we can all look at this and we can agree that this is 1/4, or 1/4 of my square is shaded in. Now I want to take this square and these pieces, and I want to split them into more pieces, so I'm going to do that. So now I've taken my larger square that was split into 4 pieces, and I've split each of those smaller squares into 4 pieces. But my larger square is still considered my whole. So how many total pieces do I have now? Well, I have 4 squares, and I have 4 squares. So I have 16 total pieces. And how many of those pieces are shaded in? 4 of them. So I went from 1/4 to 4/16 with just splitting my rectangle. How do I know that this 1/4 and this 4/16 are equal to the same amount? Well, I can look at what I have here. I haven't changed the part that's shaded. All I've changed are how many pieces my whole is split into. How would I go from 1/4 to 4/16? Well, I could multiply my numerator times 4, and I can multiply my denominator times 4. But let me ask you this. How would I go the opposite way? Let's say I started with 4/16. And I wanted to know, well, what is another fraction that this is equivalent to that looks like it's smaller than 4/16? How would I figure that out? Well, when I did this for my numerator, I multiplied times 4. What could I do with these numbers? I could divide instead of multiply. So maybe I don't think of 4, but I think of 2 because both of these numbers are even. I could divide by 2. What's 4 divided by 2 equal to? 2. And 16 divided by 2 is 8. Would 2/8 and 1/4 be equivalent? Well, let's look. How would I know if 1/4 and 2/8 are equivalent fractions? What could you do to test this? Well, I could test using some multiplication. If I do the same thing to my numerator and my denominator, is it going to give me that as a result? And when I multiply 1 times 2, it gets me 2, and 4 times 2 does get me 8. So yes, these two fractions are equivalent, which means these two fractions are equivalent and these two fractions are equivalent. When I'm finding equivalent fractions, I'm going to multiply my numerator and denominator by the same amount, or I can divide my numerator and denominator by the same amount to find equivalent fractions. So let's take a look. I'm going to create some fractions that are equivalent. Whenever it's done, whatever is done to the numerator has to be done to the denominator. Or you could start with your denominator and then work on your numerator. So we have 4 fractions here, and I want you to create some fractions that are equivalent. If I have 1/2, well, what is another fraction that is equivalent to 1/2? How about 4/6, 2/5, and 1/3? I want you to multiply your numerator and denominator by the same value to find 2 additional fractions that are equivalent. Let's start with 1/2. Well, the first thing I'm going to do to find an equivalent fraction to 1/2 is maybe I'm just going to multiply times 2. That's a good place to start. So I'm going to multiply my numerator and denominator by 2, and here I get 2/4. Notice how 2 is half of 4. So it makes sense that 2/4 is equivalent to 1/2 because 2 is half of 4. Now, if I want to make another equivalent fraction, I can keep along the same process. I'm just going to multiply this times 2. 2 times 2 is 4. 4 times 2 is 8. So 4/8 is also an equivalent fraction to 1/2. Notice that 4 is half of 8. All right, go ahead and take a look at 4/6. What can I do to 4/6? Well, some of you might have gone ahead and multiplied 4 times 2 and 6 times 2, and we can do that. But notice how both of these numbers are even. So there's something else that we can do here that would actually make this fraction have smaller number of pieces, but it would still be equivalent. Because both of these numbers are even, I'm going to divide by 2. When I do this, I'm left with 4 divided by 2 gets me 2, and 6 divided by 2 gets me 3. And when I look at this fraction, there's nothing that 2 and 3 have in common anymore. 4 and 6 both had the number 2 in common in terms of factors, but 2 and 3 don't have anything in common other than 1. This is considered a fraction that's in simplest form. We're going to talk about simplest form tomorrow, but simplest form says that the fraction only has the number 1 as a common factor between its numerator and denominator. All right, so we have 2/3. What's another fraction that we can make that's equivalent to either 2/3 or 4/6, because they're both equivalent or equal to each other? Well, maybe this time I multiply times 3. So 2 times 3 gets me 6, and 3 times 3 gets me 9. So these fractions are equivalent to 4/6. Next one is 2/5. I'm going to do the same thing. I'm going to multiply times 2. And when I do that, I get 4/10. And maybe I go back to my 2/5, and instead of multiplying times 2, I'm going to multiply times 3. And when I do this, I get the fraction 6/15. 6/15, 4/10, 2/5 are all equivalent fractions. The last one that I have is 1/3. I'm going to go a little crazy. I'm going to multiply times 4. Here I get 4/12. And then maybe here, instead of multiplying times 4, because both of these are even, maybe I'm going to divide. And I divide by 2. And that would get me 2/6. All these fractions are equivalent. We have one last thing to look at today. Here we have some fractions, and I want you to tell me, are these fractions equivalent or not? Yes or no. In order to find this out, you're going to multiply your numerator and denominator by the same amount and see if you can get the other fraction, or you could divide. Figure out what works best for you and tell me, are these fractions equivalent or not? Well, if I'm going from 2 to 6, what would I have to do? I would have to multiply times 3. Oops. Can I also multiply 3 times 3 to get 9? Well, 2 times 3 gives me 6, and 3 times 3 gets me 9. So yes, these two fractions are equivalent, because if I were to multiply my numerator and denominator by the same value, I'm going to get 6/9. Let's take a look at number 2. How would you get to 3? Well, if I have a numerator of 1, I would need to multiply times 3. And then I would need to multiply my denominator times 3. Well, 3 times 1 would get me 3, so this part would be right. But 3 times 4 gets me 12, which is not 8. So these two fractions are not equivalent. Go ahead and take a look at the number 3. Are these fractions equivalent? If I'm going from 4 to 1, what would I have to do? I'd have to divide by 4, and that would get me 1. If I'm going from 8 to 2, I would also have to divide by 4, which would get me 2, so these two fractions are equivalent. And last one, number 4. When I go from 2 to 6, I would need to multiply times 3, and that would get me 6. I would need to do the same thing to my denominator, and that would get me 15, so these fractions are, in fact, equivalent. All right, that's our lesson for today on equivalent fractions. When you're creating equivalent fractions, you need to either multiply or divide your top number and your bottom number, or your numerator and your denominator, by the same value to find an equivalent fraction. If you're looking to see if two fractions are equivalent, go ahead and test by multiplying the top number times the value and the bottom number times that same value and see if it matches the other fraction. That's our lesson for today. See you tomorrow.